Welcome to our deep dive into the world of MLOps. In this video, we'll explore how machine learning models move from development to deployment, the operational challenges involved, and the ethical considerations that must be addressed. Whether you're a data scientist, engineer, or just curious about AI, understanding MLOps is crucial for building reliable and responsible machine learning systems. Let's start by defining what MLOps is and why it's become a cornerstone in modern AI workflows. Deployment is the process of taking a trained machine learning model and making it available for use in real-world applications. This means integrating the model into existing systems, ensuring it can handle live data, and providing reliable predictions. Deployment bridges the gap between research and practical impact, turning theoretical models into tools that solve real problems. It's a critical step that requires careful planning and robust infrastructure. MLOps, short for machine learning operations, is a set of practices that combines machine learning, DevOps, and data engineering. It ensures that models are not only deployed efficiently but also monitored, maintained, and updated over time. MLOps helps teams collaborate, automate workflows, and deliver AI solutions faster and more reliably. Without MLOps, scaling AI from prototype to production can be chaotic and error-prone. MLOps lifecycle covers everything from data collection and model training to deployment and monitoring. It's a continuous process, not a one-time event. After deploying a model, teams must track its performance, retrain it with new data, and ensure it adapts to changing environments. This lifecycle approach helps maintain high-quality predictions and keeps AI systems aligned with business goals. MLOps involves several key components: version control for code and data, automated testing, continuous integration and deployment, CI/CD monitoring, and governance. Each component plays a vital role in ensuring that machine learning models are robust, reproducible, and scalable. By integrating these elements, organizations can streamline their AI development and reduce operational risks. Version control isn't just for code, it's essential for data and models too. By tracking changes in datasets, model parameters, and code, teams can reproduce results, collaborate more effectively, and roll back to previous versions if needed. Tools like Git, DVC, and MLflow are commonly used to manage this complexity in MLOps pipelines. Automated testing ensures that models perform as expected before deployment. This includes unit tests for code, validation tests for data, and performance tests for models. Automated tests catch errors early, saving time and preventing costly mistakes in production. They are a critical safeguard in the MLOps workflow. Continuous integration and deployment, CI/CD, automate the process of building, testing, and releasing machine learning models. With CI/CD, every change to code or data triggers automated workflows that validate and deploy updates. This reduces manual effort, speeds up delivery, and ensures that models are always up to date. Once a model is deployed, monitoring its performance is essential. This involves tracking metrics like accuracy, latency, and data drift. If a model's performance drops, teams can investigate and retrain it as needed. Effective monitoring helps maintain trust in AI systems and ensures they continue to deliver value. Machine learning models can become outdated as new data arrives or environments change. Retraining and updating models is a core part of MLOps. Automated pipelines can trigger retraining when performance drops, ensuring that models stay relevant and accurate over time. Governance refers to the policies and procedures that ensure models are used responsibly. This includes access controls, audit trails, and compliance with regulations. Good governance helps organizations manage risk and build trust with users and stakeholders. Ethics play a crucial role in deploying machine learning models. Teams must consider issues like bias, fairness, transparency, and accountability. Ethical deployment means ensuring that AI systems do not harm individuals or society and that their decisions can be explained and justified. Bias in machine learning can lead to unfair or discriminatory outcomes. It can be introduced through biased data, flawed algorithms, or human decisions. Identifying and mitigating bias is essential for building ethical AI systems that serve everyone fairly. Fairness means that AI models make decisions that are equitable for all users. This requires careful design, diverse data, and ongoing evaluation. Teams should test models for disparate impact and adjust them to reduce unfair outcomes. Transparency means making AI systems understandable to users and stakeholders. This includes documenting how models work, what data they use, and how decisions are made. Transparent AI builds trust and allows for meaningful oversight. Accountability ensures that there are clear responsibilities for AI outcomes. Teams should define who is responsible for model performance, ethical compliance, and responding to incidents. Accountability frameworks help organizations act quickly and responsibly when issues arise. Machine learning often relies on sensitive data. Protecting user privacy is essential. This means using techniques like data anonymization, encryption, and access controls. Respecting privacy builds trust and helps comply with regulations like GDPR. Security is about protecting AI systems from attacks and misuse. This includes securing data pipelines, monitoring for anomalies, and responding to threats. Strong security practices are vital for maintaining the integrity and reliability of deployed models. Explainability means making AI decisions understandable to humans. Techniques like feature importance, SHAP values, and LIME help explain why a model made a certain prediction. Explainable AI is essential for trust, compliance, and ethical use. Human-in-the-loop systems combine AI with human oversight. Humans review and approve model decisions, especially in high-stakes scenarios. This approach helps catch errors, improve fairness, and ensure that AI supports human values. Model drift occurs when a model's performance degrades due to changes in data or environment. Detecting drift early allows teams to retrain models and maintain accuracy. Automated monitoring tools can alert teams when drift is detected. High-quality data is the foundation of reliable AI. Data quality assurance involves validating, cleaning, and monitoring data throughout the MLOps pipeline. Good data practices reduce errors and improve model performance. Scaling machine learning systems introduces new challenges. Teams must design infrastructure that can handle large volumes of data and requests. Cloud platforms, containerization, and orchestration tools like Kubernetes help address scalability in MLOps. MLOps is a team effort. Data scientists, engineers, and business stakeholders must collaborate closely. Shared tools, clear communication, and defined roles help teams work efficiently and deliver successful AI projects. A model registry is a centralized repository for storing, versioning, and managing machine learning models. It helps teams track which models are in production, their versions, and their performance. Model registries are essential for organized and efficient MLOps. Continuous integration and deployment aren't just for code, they apply to data too. Automated pipelines can validate, transform, and deploy new datasets, ensuring that models always use the latest and most accurate information. Infrastructure as code (ISC) means managing and provisioning computing resources through code. Tools like Terraform and Ansible automate infrastructure setup, making deployments faster, more reliable, and easier to reproduce. Model serving is the process of making trained models available for real-time predictions. This can be done through APIs, batch processing, or streaming. Efficient model serving ensures that AI solutions are responsive and scalable. A feature store is a centralized platform for managing and serving features used in machine learning models. It ensures consistency between training and production, making it easier to reuse features and maintain high-quality models. Experiment tracking helps teams record and compare different model runs, parameters, and results. This transparency supports reproducibility and helps teams learn from past experiments to improve future models. Model validation is the process of evaluating a model's performance on unseen data before deployment. It helps ensure that models generalize well and don't overfit to training data. Validation is a critical quality check in MLOps. Model staging involves deploying models to a test environment before full production. This allows teams to test models with real data and workflows, catching issues before they impact users. Staging is a best practice for safe deployments. If a new model causes problems, rollback strategies allow teams to quickly revert to a previous version. Automated rollback mechanisms minimize downtime and reduce risk, ensuring that AI systems remain reliable. A/B testing involves deploying multiple model versions to compare their performance. This helps teams choose the best model for production and gather real-world feedback. A/B testing is a powerful tool for continuous improvement. Shadow deployment means running a new model alongside the current one without affecting users. This allows teams to test new models in production conditions and catch issues before a full rollout. Blue-green deployment is a strategy where two identical environments, blue and green, are used. Teams switch traffic from the old to the new environment, enabling seamless updates and easy rollbacks if needed. Canary deployment gradually rolls out new models to a small subset of users before full deployment. This approach helps detect issues early and limits the impact of potential problems. There are many tools for monitoring deployed models such as Prometheus, Grafana, and custom dashboards. These tools help teams track performance, detect anomalies, and maintain high service quality. When issues arise in production, a well-defined incident response plan is essential. Teams should have clear procedures for investigating, communicating, and resolving incidents to minimize impact and restore service quickly. Running machine learning systems at scale can be expensive. Cost management involves tracking resource usage, optimizing infrastructure, and choosing cost-effective solutions. Efficient cost management ensures sustainable AI operations. AI systems must comply with laws and regulations such as GDPR and HIPAA. Compliance involves documenting processes, securing data, and ensuring transparency. Staying compliant reduces legal risk and builds user trust. Sustainability means designing AI systems that minimize environmental impact. This includes optimizing energy use, choosing efficient algorithms, and considering the lifecycle of models and infrastructure. The future of MLOps will bring even more automation, better tools, and stronger ethical frameworks. As AI becomes more integrated into our lives, MLOps will play a key role in ensuring that these systems are reliable, fair, and beneficial for all. We've covered the essentials of MLOps from deployment and operations to ethics and governance. By following best practices and considering ethical implications, teams can build AI systems that are robust, trustworthy, and impactful. Remember, successful MLOps is about more than just technology, it's about people, processes, and responsibility. Thank you for joining this journey into MLOps deployment and ethics. As AI continues to evolve, staying informed and proactive is key. Embrace MLOps as a holistic discipline that combines technology, teamwork, and ethical responsibility for a better AI future.